Section 8.4, synthetic division. The objective here is to use synthetic division to divide a polynomial by a first-degree binomial. So we'll apply the same logic that we used in long division, but now we're specifically going to look at when a polynomial is divided by a first-degree binomial. So in this case, we're not going to be dividing by quadratics. We're going to only be dividing by linear expressions. Now what this is really is an efficient way to divide a polynomial by a binomial, and if this is true if the binomial is in the form x minus c. So if we were dividing 2x squared plus 4x minus 8 by x minus 4, well then c is 4 in this case. And we'll see, no pun intended, we'll see in a moment how that value plays a role in synthetic division. But if I were dividing something like, 3x squared plus 5x minus 7 over x plus 2, well, now we have to ask ourselves, what is c? Well, c is negative 2 in this case. The reason being is the only way this could be written in the form x minus c is if you wrote it as x minus negative 2. Because x minus negative 2 is really x plus 2, but we want to write it in the form x minus c. So this is c right here. So let's look at example 1 here to go through the process of synthetic division. And then once we know the process, it just becomes a matter of practicing. So the way we look at synthetic division is similar to that of long division. We start with what looks like a division sign, actually. Now, we also identify c. c in this case is going to be 3. Because if I remember, it's x minus c I'm dividing by, so 3 takes the place of the c there. You start by putting the c value on the outside. So again, this is very much like long division. Right? This is our divisor in this case right here. So it's like it goes on the outside still, but without the x. Okay, it's all going to be numerical. We're going to have no variables involved in the process till the end. Then we take our coefficients of the part that we're dividing into, the dividend, but it has to be in order. So let's rewrite this in order as negative 2x to the fourth plus 0x to the third plus 3x squared plus 7x plus whatever the constant is, which is 0 in this case. So we list the coefficients, negative 2, 0, 3, 7, 0. So again, where do they come from? They come from the dividend when placed in the correct order, accounting for the placeholders of zeros. Now the way to do this is to bring down the first column. So take this negative 2 and bring it down. Always, always, always. Next, we multiply these two and then add it to this number. So it's going to be multiply and then add. So multiplying these, we get negative 6. Adding that, negative 6 and 0 is negative 6. We then do this again. Multiply and then add. So 3 times negative 6 is going to give us negative 18. Negative 18 and 3 is negative 15. Again, it's like we're distributing this 3 to everything. Multiply, giving us negative 45, and then add, giving us negative 38. And then finally multiply, giving us negative 114, and negative 114 plus 0 is negative 114. Now what you'll notice here is that we've currently just gone through the process of dividing a x to the fourth expression by x to the first, which means that the result has to be x to the third. It's got to be 1 degree less. So this is really just negative 2 x to the third. And then from there we go down by 1 degree each time. Minus 6x squared, minus 15x, and then here's our constant, minus 38. Well, what do you suppose this is? This is our remainder. This is our remainder. Just like in long division we had a remainder, minus 114 over whatever the divisor was, which was this up here, this x minus 3. So this turns out to be the quotient. Even if we check this with long division, if we take this quantity, the dividend, and divide it by this quantity, the divisor, this is the result we would get using long division as well. So again, remember that this term is always 1 degree less than your original dividend's highest degree. Example 2 says, divide 2x cubed plus 9x squared plus x minus 12 by the quantity x plus 4. So start by thinking about this as x minus negative 4, so you can identify that c is equal to negative 4. Once that is known, just put a negative 4 out here. Then look at this. Well, this is in order, and there's no missing placeholders. 2, 9, 1, negative 12. Bring down the 2, multiply, add. So we'll get negative 8 plus 9, giving us positive 1. Next, multiply. That gives us negative 4, plus 1 gives us negative 3. Multiply, giving us positive 12, 12 plus negative 12 is 0. So it looks like my answers in this case are going to be 2x squared. I know it's squared because this was x cubed, plus 1x minus 3. Now the remainder is 0, so there's nothing left at the end. Well, this comes into play again, just like with long division. When the remainder is 0, we know that this ends up being a factor of the dividend. So it turns out that this dividend up here has factors of x plus 4, and this quantity at the bottom, 2x squared plus x minus 3. Again, when the remainder is 0, it divides evenly. So as a result, we can say that 2x to the third plus 9x squared plus x minus 12 factors into x plus 4, which was our first divisor we were looking at, and the quotient we got with no remainder. Example 3 says, in electrical engineering, Ohm's law is used to relate resistance, voltage, and current. If these variables are all functions of time, then Ohm's law says V of t equals I of t times R of t, or simply put, V equals IR. Find the current I of t if the voltage function V of t is 2t to the fourth minus 3t squared plus 4t minus 7, and the resistance function as a function of time is t plus 2. So we're going to go ahead and take a look. We're going to say, well, V equals IR. We're looking for I, so we'll solve by dividing by R. We get V over R equals I. So take this function for V and divide it by this function for R. So in essence, we're going to be able to use synthetic division. So we're taking this quantity, let's put it in order. It's going to be 2t to the fourth. Now there's no t cubes. There's a minus 3t squared, positive 4t, and a negative 7. And then the c value in this problem is a negative 2. Because I see this t plus 2 here, it's really written as t minus negative 2. Let's go through this process. Bring down the 2. Multiply, giving us negative 4. Add, keeping negative 4. Multiply, making that 8. Add, making this 5. Multiply, making this negative 10. Add, making this negative 6. Multiply, making this 12. Add, making this simply 5. So as a result, we get 2t to the third minus 4t squared plus 5t minus 6 plus 5 over the quantity t plus 2. And that's a remainder at the end there, again, of 5.